You're going to hear me swearing and making bad jokes. There we go. All right, so today we're looking at exploring the data. Sorry, I forgot to put my glasses on. And I have on here, making friends with your data. I think I got that from Andy, which might sound kind of like nerdy to say, but in order to do good data analysis, the very first step is you must explore the data. I stress this a lot because when I first got here and would help a lot with other people's stats, like my profs, and master students too, I found that no one ever did this step. And almost everything that they were having trouble with would have been resolved if they had gotten to know their data in the first place. So today we're kind of I'm showing you more of an example from my world, social sciences, like a large survey data set, but this is important even with repeated measures. For example, I do a lot of work with Fabien and Dwayne and Kevin, and they spend tons and tons of time like looking at the data, figuring it out. But as an example, you can also just tell if there's something wrong by the values. For example, this one data set, it was that something similar to what Gareth is doing, this upper body, lower body sprint one that Dwayne was involved in. And Fabien did, I guess, the heart rate part of it. So I noticed that there were some odd data points. I don't know anything about heart rate or exercise fits though. So I just made a note. I showed it to him and he's like, oh, something's wrong. The students had taken their heart rate, he said manually. I don't know what that means because like all heart rate is manual. Like I don't know. Or what are you doing auditorily? I don't know. Anyway, but you could see then that things were wrong. Like if someone's at their 8th sprint and their heart rate is only, 90 beats per minute, that's what you recorded, something's wrong, right? You know then from those values that something is incorrect. So you need to kind of look at all these. The other reason we have to care about this is because most inferential statistics rely on specific assumptions. So what we're learning in this class is mostly parametric testing. So it's based on normal distribution. So we're expecting our data to follow a certain curve. And there's other assumptions. So we have to check to see whether our data actually meets those assumptions. And if you're doing a statistic and your data doesn't meet the assumptions, then you're doing errors. It's called statistical invalidity, and there's a lot of problems. So it's important to first look at the data. Students typically don't spend enough time on this, and I think it's because it's not fun. You want to quickly run everything, see your p-values. Everyone's into p-values, but you have to think about what tests can you do? So one, you have to look if it's normally distributed. Okay, so for example, my student Kenny, Joshua, you wouldn't know it. He's in 3rd year, so yeah, he probably doesn't come to seminar. So he's an Indian guy you might see around. He was looking at his main variable, his main outcome variable. He's doing a StatScan data analysis on looking at the differences in immigrants based on various, health factors, looking at people who've been here for 0 to 9 years versus 10+ years, okay? And he's looking at life satisfaction was the outcome. It's not normally distributed. So Chrissy comes to my office crying, not really crying, but whoa, I can't even do what I wanted to do for my whole thesis set. Like, well, we can do something different then. At least we know that. We then collapsed the life satisfaction so that it was just high and low life satisfaction, changed the variable. Now we're going to do a different type of statistic though. But at least we knew that before, he got going into it. So we know that this is the normal distribution. It's actually the technical word for it, if you're doing readings, is Gaussian. Okay, Gaussian is just the dude's name who invented it. There's many other types of distributions, but obviously this is based on, it's a bell-shaped curve. And Gauss, his name's Gauss, sorry, he used, just if you want to know how he developed this, it's based on Pascal's triangle, is how this all got developed. Remember that from grade 7? I barely do, but I remember having to solve these triangle things. So we have to look at that. If it doesn't follow the shape, then we have a distribution. Also, it tells us a lot about what's going on with the data. So one of the things we want to look at is if the data is skewed. So skewness refers to lack of symmetry. So symmetry this way, okay? Think of it like you're looking at, do each of the half of the bells look the same? The lack of symmetry then, if we look at it with the normal distribution, and so skewness can be positive or negative. So when, I'm just gonna, do I have? Oh, I do. Okay. It can be positive or negative. And if you don't have any skewness, it means that it's a perfectly symmetrical distribution. Now, SPSS gives us skewness statistics. We don't actually have to calculate it, okay? But you should be visually looking at your diagram too, and then it'll to look at things. But you can also tell if the mean, if the average equals the mode, then it's a perfect distribution. It's normally distributed. If, however, if the mean is greater than or less than the mode, you'll have positive or negative skewness. So here we have that the skewness is positive, and here the skewness is negative. So you can see the way that I remember, I mean, I guess these are the positive numbers, but anyway, I won't, maybe sometimes it's not a good idea when I explain this, but because it might not be how you remember. But I just remember that if everything's clumped close to the axis, it's positive, and if it's clumped on the other side, then it's negative. So you need to look, so we can see from here what we might look at this and think, what does this actually mean? As an example, in Kenny's data for life satisfaction, we had this distribution, okay? Greater scores meant greater life satisfaction. So what would I know about that population then, if I see a negatively skewed distribution? But let's say it's life satisfaction, positive scores are greater life satisfaction. What would it mean then if you saw this? It would mean that most of the participants had what kind of life satisfaction? Good or bad? Good, right. So we could see then, one of the problems that we had in that data set then is that the data, there's not a lot of variability. Most all of the people had, a pretty good life. So that doesn't mean that the data is bad, that's just the reality, but we have to kind of analyze it differently because it isn't normally distributed. Most of the time when you're dealing with humans and feelings, attitudes, that kind of thing, you'll find that you hardly ever get normal distribution. It's actually quite uncommon. In physiology types of measures, they're almost always normally distributed because it follows, it's physiological rules, okay? So they're more likely. So it's kind of funny. In my world, I might have a sample size of 500 people, but it won't be normally distributed. You guys get like 8 people, and it is normally distributed. So, so you're going to learn in this class, for every single assignment, you're going to explore the data, you're going to look at the histograms, and you're going to make a comment about the distribution of the variables. And then I'll tell you there's also scores that you can look at as well. We then have kurtosis. Who's heard of kurtosis before? Couple people, okay. It's a way of describing how peaked the distribution is. So this is the normal distribution, but if it's smushed like that, it pushes out the tails, and it's called platycurctic. Where if it has a great big peak like that, we call that leptocurctic. So platycurctic has many scores in the tails. It's quite flat. Lepticurctic has thin tails. So you can see on this one, it has to do with how large the standard deviation is. If you have a large standard deviation, it's more likely to be flat, a flat-looking picture. And you can see it looks like a plateau. And here we've got things very smushed into a peak. The way that so again, you would want to look at these at your histograms and say, does it look platycurctic or leptocurctic, or is it fine? How do you remember the words for these? This is how I remember. Platycurctic, plateau. It kind of looks like the MUN logo, which I kind of look weird. Lepticurctic, you have to leap over it to get over it, right? Lepty, you leap over the big peak. That's how I remember. Lepticurctic. We also have to look at other assumptions of parametric tests. One is homogeneity of variance, and we'll talk about that again. And that is for between subjects design. So between subjects is when you have two independent groups. For example, we might have people doing an exercise program. Some of the people let's say they're highly trained athletes, and others are recreation athletes. They're independent groups. So like independent t-tests. Sphericity is for within subjects design. That's repeated measures. So for when we learn about t-tests or ANOVAs, we're going to learn about homogeneity variance. When we look at repeated measures ANOVAs, we're going to have to look at sphericity. And if you do a mixed design, which means you have repeated measures but two groups, you have to look at both of these. These are things that no one in this building really knew about until I started teaching this class. Dave always laughs like he didn't even know what the word sphericity was, and now he uses it in all of his publications now. But I want to stress again without putting down Dave here, okay? But what that means is that no one freaking checked the assumption, ever. No one was doing the correct statistics because they didn't check about normality and they didn't check for these other assumptions. There are lots of, and I think a lot of the times is because researchers don't want to know that they're violated, but just because it's violated doesn't mean you can't run your stats. For example, there's another line you read for each of these, and there's just a way of correcting for it, okay? So just because it's violated doesn't mean anything. Same with normality. You can do bootstrapping and change the data. Doesn't always work. The other assumption of parametric tests is that the data has to be measured, or at least your outcome variable, at the interval or ratio level. So it means that you can't, if your data is at the ordinal or nominal level, then you do what's called non-parametric testing, right? Also, we'll learn about this later, but if you guys might have read, who here is when you're pretending to read your journals articles and you really skip a lot of it, you guys might recognize some of these words. The Wilkinson ranked test. Have you guys read that word ever? No? You guys don't read you really don't read your articles. All right, the Mann-Whitney test, okay, these are common ones. these are used if you've got ordinal or nominal data, but you can also use them if you don't have if you don't have normally distributed data. You can also use them if you have if your sample size is too small. So there's ways of, I guess what I'm trying to say is, like there's absolutely, I've never ever been given a data problem and I couldn't do something cool with it. It just wasn't what the person planned. So it's important that you think about this and don't just, like, I always tell people, in your research proposals, you guys are going to say what your stats you're going to use, right? In a way, that's not a really good system, because what if you've got a plan, you're going to have a stats plan, but you do not know what you're really going to do until you explore your data. Same with, you're going to learn in this class, it is incorrect to say what type of post-hoc test you're going to use for an ANOVA. I see it every bloody thesis presentation. Because you can say, I might use one give them a flavor of the different ones you might use, but you shouldn't really pick it until you've explored your data, because there's reasons why you would pick different ones. And it's based, again, on all of these different assumptions. So, you guys probably you'll see this assignment, it won't take you forever, but in, I might explore my data for 1 whole month. Okay? We get to know each other. We go on lots of dates. We make love, make love with your data. That's what you gotta do. Okay? So the other reason that I'm stressing this again, that you want to collect data at a high level of measurement and more precise, particularly ratio, is that if your research question requires that you use a parametric test, you need to design your study so that you're collecting the data at that level. Now in XViz, you're not going to have to care about that as much, but for example, in survey research, it's really easy to not measure something, right? If you use too many categories. And again, you need to think about what each level of measurement is for your data. Independence. Independence is very important. Data from different participants are independent, which means the behavior of one participant does not influence the behavior of another. This is an assumption of all between subjects designs. So not repeated measures, but between subjects. And so you have to make sure that your data is independent. And I'm going to give an example of, well, 2 examples of when it might not be. Here we've got, let's say I'm determining if some sort of water exercise program helps arthritis for seniors, okay? I'm doing it over here at the Aqua Arena. So you can see she's enjoying the, I'm going to call it AquaFit, because that's just my word. But I realize that's not a common word now for it. What do they mostly call it now? Aquasize, or?
We call it AquaFit.
You still call it AquaFit?
Yeah.
Okay. I've said that before and people didn't know what I was saying. So anyway.
I think it depends on like each school.
I think it also depends how old you are. But anyway, and then we've got control group who's not doing the exercise at all, not doing in the water. It could be, and by the way, this happens a lot in Newfoundland, by the way, this type of errors in research. Of course, they know each other, right? And they see each other at Tim Hortons, right? And she says, Betty, I'm going to teach you all the exercises I'm learning. Come to the pool tomorrow, and I'm going to show you. And then Betty starts doing the routine. She messes up our entire experiment, right? And therefore, we no longer have independence. We have violated that assumption. From a practical point of view, how could I design my study so that funny, what do you call it? I can't remember. Swim hat lady doesn't talk to Betty? How would I do that? How would I make this study better so that they don't talk to each other? Don't not be rude. Yes.
Gonna put them in different cages. Whatever.
Well, yeah. You could, one, you'd have to stress to your participants, do not speak to anyone about this. If you tell, we have people in a control group, if you tell them the experiment isn't gonna go well. And we'd also say, don't worry, once we're finished the study, we're gonna switch them, or we're gonna give the whole exercise session to the control group. So don't worry, Betty will, get the exercises. Another thing we could do is do them at different pools to, different locations. That would help. But so a lot of people don't talk about this type of thing. But in Newfoundland, this type of stuff is very common because there's so few people. And if you're doing research in rural areas, who lives in a rural? From rural, yeah. One person, someone breaks a teacup and everyone knows about it and by the afternoon, right? So, can't do that. Another thing I have chalk. Did I do it?
There's chalk over that eraser.
There's a whole thing?
Yeah.
Okay. I even was really organized. I cleaned up my bag. I found really weird stuff in there. Anyway, all right. Once I had people were doing a study where they were looking at it was repeated measures, and they had an N of 8, and whatever their protocol was, they did it for the left leg and then for the right leg, right? 8 people is not very many, okay? So they were having a hard time recruiting participants. The researcher approached me and said, can I just say that I have 16 people, and some of them were the left leg and some were the right leg? So basically saying that, so these were the same people who did it, right? So they wanted to pool it together and just pretend it was legs and not care if it was the left leg or right leg. And so basically saying that basically they're lying then, and they're pretending that they had an N of 8 that did the right leg and an N of 8 that did the left leg. Now, one thing I said to them was, how are you gonna, well, one, it's called cheating and lying, okay? 2, it violates the rule of independence, even though it's repeated measures, it still would cause problems. And 3rd, I said, what rationale would you give at all for the left leg or the right leg? Why would you pick, do you know what I mean? It doesn't make any sense. So this kind of stuff happens quite often. People try to get away with this, but it violates independence because you can't compare 2 groups when the same body part came from the same person, right? It doesn't. That was sorry, totally off topic, but in grade 12, chemistry class, I received a 3rd-degree base burn on my face, okay, from titrations. And it was just from the fumes coming up, I was that sensitive. Anyway, my mom, Mother Bear, as everyone called her, everyone knew my mom at school, and she, so I went to the principal, I washed my face, of course. I had to go to the principal's office, and this is what he said to me, because he's trying not to get sued or something. He was a real ass, too. He said, how could you get it, aren't you right-handed? How did you get it on the left side of your face? And I went like this to him. Oh, look, I can touch my face with my left hand, too. Anyway, and I'm ambidextrous, actually, so it doesn't matter. Anyway, and then my mom phoned up someone she knew at the University of Waterloo chemistry department, and then got this whole list of blah, blah, blah safety things. And basically, she went to the principal and said, if you didn't stop bothering me, because I had a lot of health problems, so I would be absent from school a lot sometimes. And anyway, basically, she threatened suing him. The next year, I had first period spare, and everything was great. Special locker. But I guess you shouldn't really do that. But anyway, I don't care. My mom was awesome. I now learn all the things that she did. Although she also did awful things. She would, before I would go on a date, she would like drive, like, she always wanted me to give the person's address. I thought it was like just a safety thing, you know, like, so you know where you are. She would drive to the guy's house and check it out and sit there, wait for his parents to come in or out to like see what kind of house they had. Like, I don't know what she was gonna tell from this. And then if she didn't like what she saw, all of a sudden we would be going away that weekend. Like, seriously. Anyway, I never knew how manipulative she was, but it was probably for good.
Did you spend a lot of weekends away?
Yeah! Anyway, I didn't know. She did this with friends too. Yeah, well, now that I think about it, yeah, my mom's theory is like, if you don't like the boy, send your daughter to Europe. That was her philosophy. Yes. I did get sent to Europe in grade 11. So I don't know what boy it was I was dating. Anyway, here is repeated measures. Repeated measures, then you have the same person who is acting as their own control. The same person. So here we have, in repeated measures, the assumption of independence is violated across the participant. What Bob does at time 1 is obviously going to influence what he does at time 2 and at time 3, because it's Bob. Whereas, and up here. So across the times, it's not independent, but it is independent between subjects. And this is the power of repeated measures. It's not good for everything, but this is why it's used so much in kinesiology, is because you're able to have fewer people in a study, still be able to run the stats, and the individual is kind of acting as their own control group. So, I have happy face. All right. I just want us to, we're going to get to know the data set. And I'm sorry, I should have had D12 open to show you what to look at here. I'm going to just go over this fairly briefly. This used to be the data set you would use for stats assignment number 1, but then I found it was too easy for people, so I have a different data set. If you go to stats units and then exploring the data, you will see class handouts and activities. And here is data set and information for in-class activity. I'm looking at one of these. I just want to download this. Oops. Okay. So, very brief, just so you can understand a little bit. The data we're looking at today, it's not data that a lot of you will come across, because it's survey research data. But it's important for you to understand this. For example, you might be analyzing survey research for our fly fishing project or something, right? So you need to know. Or you know that from after you take this class, you could apply to Stats Canada to get a job. You can, if you can do any like data analysis, data management, that's a job. So you don't want to just know how to do repeated measures data, because guess what? No one uses it in the whole world except for kinesiology people, really, okay? It's not a very common design. And so it's important that you see all types of data. So this data is from the, let me just close this. My project it was called FRIL, Family Relationships in Late Life Project. So it was looking at caregivers and care recipients. So a caregiver is someone that, I call them informal caregivers, but that's not the PC way. No, it's now an unpaid caregiver. So usually someone who is, you know, like a daughter or a spouse who's looking after their husband or their mother or aunt or something in their home. In most of the world, where many people come from, people look after their family, and it's not a big deal. In Canada and the US, after World War II, we pooped out the old people. We say, you will not live with us. And we kind of shoved them in homes. And now it's coming back. Well, my grandparents shoved their parents into a home like in 3 seconds. Whereas in today's society, it's more long-term, you know, trying to have people independently live. So we were looking at the caregiver as well as the care recipient. We followed them for 3 years, the same data. Notice at time 1, I had 310. Time 2, I had 214. Time 3, I had 159. This was only 1 year intervals. Why? So that's almost half of my sample was gone by time 3. Why? What was my attrition? The reason attrition is a fancy word for dropping out of a study. There's lots of reasons. People could move. Why else would someone drop out of a study? Move, yeah, die. They just don't want to be in the study, okay? 100% of the people who were not finished the study died. 2 years. 2 years, it went from 310 to 159. So I want to emphasize this. When you're working with certain groups, especially older adults, you have to oversample. So they knew, we knew that we needed to get a certain number because probably in so many years, it was going to drop out. Okay, so you have to oversample. Now, you should do this with repeated measures designs too. People constantly have people who don't finish it, especially if you have undergrads. Undergrads are just awful. They get a date, they're not going to show up. They, don't feel well, all these reasons. So it's important, it's better to try to recruit more people as well, and then phone them up and say, oh, I actually don't need any more people now, than to do it the other way. I find here, it's more like a scrounging to find people, and I think, well, why not just try to find a whole bunch of people at first, and then figure it out. So we collected things like, sociodemographics were age, and you can see, so we have date of birth, etc. Now, why did I do, notice here, I've collected it at what is your date of birth? Why? Because then I could exactly calculate it, not a category. At time 2 and at time 3, we didn't collect age. Why would we not collect age? Again.
No.
You already know it. Your birth date is not going to change over the years, okay? Unless you're my great aunt. She's had 2. 1 year we had her 90th birthday party, and then she found some papers and realized that she had her birth year wrong, and so then the next year we had another 90th. she is, I'm sure so yeah, my grandfather is 97 and my great aunt is 99. And last year their oldest sister died. She was 101. So I'll be looking after my mom a long time. We asked relationship to the caregiver, so kin, like are you the mother, father, daughter? We also looked at, do they have Alzheimer's? We asked that. Research shows caregiving for someone with Alzheimer's is really hard, okay? Sex, ethnic background. So you remember, in the States, they use the term race. We don't use that word. In Canada, we use ethnicity. They have different things. So race is genetics. Ethnicity is a mix of genetic and culture. Care about culture. So like in the States, for example, every form I filled out, I was supposed to say if I was white, black, or Hispanic. Right? I said none of your business at the time, but they count all that stuff. Marital status, education level, employment, occupation, income, okay? Now, very briefly, activities of daily living. There's 18 items. And so they're asking, like, you know, do you need help to bathe or prepare meals or blah, blah, blah? Or this is, sorry, how much do you help your care recipient? Pardon me. Oops. And you don't need to know all about this, but this is the ISEL is the interpersonal support evaluation list. It's looking at social support. Little tip here that I want to comment on. So it's important that you double check how things are measured, and slow down. I didn't explore my data well at first in my PhD. Okay, and I forgot that this scale had some scores that were reversed, that you're supposed to reverse them. I did all of my analysis, 3 months of analysis. For some reason, I went back and I thought something's weird, and I looked and I had calculated this variable incorrectly. I cried and cried, okay? Now, it didn't take me long to redo my analysis because I had logged each step. I had saved all my codes in Syntax so I could just rerun it. I'll show you how to do that, but you can just save what you do in SPSS into a Syntax file, and then it's all logged. Then, when you want to run it again, you highlight it, push a button, and it does it in 3 seconds. Another example of this is Kenny. Kenny is looking at, I told you the immigrants, Canadian immigrants. Dr. Fuller is on the committee and wants him to do a weighing of the survey because it's a population one. I don't know if it's going to work, and I'm fighting that we don't have to do it. Okay, I'm like, Fuller, if you don't know how to do this, so why the hell should Kenny do this? But anyway, that's my opinion. But I'm still working on this rationale here. Come on,
I think that's pretty good.
yeah.
Directional,
Yeah. Anyway, and I realized he didn't know what he was doing. He's like, well, here's the paper I did. This is how they did it. I'm like, so you didn't do this? No, I've never done it. Well, anyway, so, but we're redoing it. If Fuller makes us weigh it, we can then rerun the whole thing really fast because we've just got it all documented and it won't take long. So if you document things, that's when, and if I had properly made love to this variable to begin with, I might have noticed the mistake. Then I have activity restriction. This is one that we're going to use a lot today. So activity restriction is, they asked, I think it's 8 items, and 9, A1 to A2. So they're looking at how restricted are you in your activities because you're a caregiver. So 0 to 4. and you add all of these up. So in the data set you're going to see there is ARS 101. That means it's the first item at time 1. ARS 201 is that item measured at the second time. So you can see that you name your variables things so that you can understand them, when you look at the data set. And last we had depression. It's a 20-item measure, how sad are you? You add it up together. And physical symptoms, another checklist, and subjective health status. So if you open up this data set, which is called I just have to see. Make sure you're open the right one. It's called Explore. And you will see this is what a real data set looks like, not like the kinesiology ones. Okay? You see, this is my ID. I know it's hard. Do you guys know how I could make this bigger? I don't know if it does. I don't think I can zoom it. But you'll see it says ID. And I've got I don't think it's going to do it on SPSS. And I don't have a mat no. ID. So it's important that you always have an ID value. One, on a survey, pretend these are surveys that you handed out. Why do I care about having an ID? Because I would put an ID here, and then I have the ID here. This is different than what you have as your consent form. Okay? You keep your consent forms with the name and the code that you've given them in one place. Your raw data is in another place with just their code. And then you have it in SPSS. This way, for example, if I realized that I made a mistake entering the data, and I knew it was person case 1041, I could then go back into my file, find survey 141, pull it up, and be like, oh, okay, I typed that in wrong. It's really easy as a human to make mistakes. The other reason is you have to keep track. For example, I forget his name, but he's a PhD student. I met him, Hamid, I believe his name. He's also a Hamid.
Hamid, or Hamid.
Hamid? His name is very long with this. Okay, and yeah, he came and asked me a stats question. He didn't have an ID. He had no ID, okay, in his data. That means that if something happened and you just accidentally deleted someone by mistake, or you someone you had to take out, you wouldn't know who you were removing. Like you must put a name, because if I just put, you shouldn't be relying on this thing. I could put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but what if I delete person 3, 7, and 9? Then it goes, you can't tell who they are.
So where do you, for this ID that's in SPSS, where do you associate this ID with the name? Do you put it in the variable view?
No, I just put ID. And then if you needed a name, you would have maybe a separate Excel file that would have, like, Kevin is 1, okay? Yeah. A very common thing that I see with Dwayne, at least anyway, and Kevin and Dave. And all of them, I guess, okay? In the bloody Excel file, they put people's initials. Okay? That is unethical, because we can figure out, I know, there's hardly anyone in this building. If it says, MT did the study, ooh, I wonder who it is. Like, I'm gonna be able to figure it out. Or like,
You say to do initials backwards.
oh, that's true. I always like, so I always get people coming in and helping me, like, who is this one? And I'm like, and they're like, oh, they didn't do it very well. And I'm like, oh, it was Evan who did not maximize his voluntary consumption. You know, like, it's not ethical, and I know it's kind of fun, but it actually creates assumptions. You're not doing biased or unbiased research then. Plus, if ethics actually ever caught you, like you're violating ethics. Okay, so you shouldn't do that. You can see in this is what a real variable view looks like. I've got all the names. I've got exactly what all my labels are. I have all my values, etc. It's beautiful. I did this not 20 years ago. I was going to say 20. No, I know. I did this study 15 years ago. I can still look at this data set and know exactly what all the variables are, everything about it. And this is important because you're going to share your data. Like people around here, we give data to you guys for 6,000, or you might put your data on an open data repository, or there's lots of reasons you might be sharing data. Then if you don't have this all nice, the person's not going to know what you did. You know, this is the code that tells you how to do this. So it's important that you've got a very beautiful variable view. An example of someone who didn't do this, I helped, remember in my PhD, some profs were writing a book based on a study they had done. They had collected some survey data, and they'd done this 10 years ago, like it was old. They couldn't remember what scale they had used to measure something. Okay? Just awful. Terrible document. See, I mostly learned from people's mistakes, okay? They didn't document. I opened up their SPSS file. Oh, like, I couldn't tell it just said hardly any code, that, like, I have no idea what any of it was. So I then, from the data, I could kind of figure out that they might have had 10 items. It was a social support scale or something. I then researched every social support scale I could possibly find, figured out which ones had 10 items, figured out which ones might be on the same scale, and then gave them a recommendation. It took me a week. 1 week of time because they didn't document. So, and make sure that you save. You want to say another tip too is if you do a lot of weird stuff with the data set, always never ever make a big change to your data set until you've saved it as a new name. Okay? You want to keep your one data set, save it as a new date or name, and that way if you make a mistake, this will happen, you can at least go back to the original. Okay? Your cat can walk on this computer and delete cases. I've seen it. Okay? My children have deleted cases on me. Oh, mommy, what's this arrow button do? Ah! But I didn't freak out because I had a backup, right? The other tip is, sorry, I'm just giving tips now. Do you only keep all of your assignments and your data on your laptop? No, that is really dumb, right? You save it. You didn't. We had email, but I didn't have all that stuff. And I saved mine. I emailed my stuff to my parents. I sent it to my Gmail account. I sent it to my Monday account. I had it on a thumb drive. I had it at school in in my desk. You put it everywhere. Now we have something that's much easier. What would you use now? Google Docs, or I personally like Dropbox. Okay. Which, by the way, technically speaking, Dropbox violates ethics, but everyone does it, so it's okay. Dropbox is technically housed in the States. Therefore, because of the Patriot Act, the American government could read my data, right? Because it's in the servers in the States. So you don't need to do that. I had a friend, I can't remember his name right now, but he was when I was doing my PhD, he was doing his master's. He collected his whole master's thesis. He had most of it written. He had it only on his laptop. His laptop crashed. It was going to be $1,000 for data recovery, which he didn't have, and he did not finish his master's. Okay?
Did you hear about the guy over there at Science Building? He had his thesis basically done, his laptop got stolen,
Yep.
and I guess he never ever finished his thesis. I don't know, I guess he had to do it over, as far as I know.
And the guy
He said-
Well, I'm sorry. He should have failed for being a moron and not, sorry,
They were
like, back up your stuff.
they were like, you didn't back it up, like, I guess he never, like, he said it took him 2 years to do it.
I feel bad, man, but
It was on the news.
anything will be on the news here.
It was-
The guy who put his laptop on, is that the same guy who put his laptop on the top of his car?
They found
Christmas,
his
he
laptop.
found his laptop, but he put
No.
it on top of his car, put his dogs in the car, and then
Drove off.
drove off, and the laptop fell.
No,
That
this
is
got
how
stolen out of his
Our
office.
iPad got a crack in it. But all of a sudden, we were driving, my husband hardly ever brings his tablet. We were driving on Elizabeth, he's dropping me off. We had the kids in the car, all of a sudden I hear Matt say, "Oh, shit." And look, in the middle of Elizabeth is the tablet. And he like has to, we stopped traffic, he gets out. Anyway, it had a crack. And, but yeah, anyway, there's no reason to do this. Like, I mean, I have my students I have a shared Dropbox with each of my students, and I make them they tend not to use it as much as I do, but I make them put all of their data and each chapter and everything, each week, I want them to be in that Dropbox. So. All right, now what are we doing? Sorry. So there's lots of, you can see the various data. Why?
Why the different goes from divided into screen divided ones and dates?
Oh, because that's just how they would have, well, we collected it that way so we could get a precise age, nearest birth date. Okay, so your working class, for example, I mean, the easiest way to calculate age is obviously take what is the year now, subtract, right? But if you want to be totally accurate, you would look at everyone who, if you're, depending on what time it is. So for example, my birthday is in August. So that is 7 months now away. Therefore, my age nearest birthday is still 42, because I'm going to be 43 in August, but that is more than 6 months away. This is like to be totally accurate, okay? They do that. I told you, like in actuarial science, that's how they do it. So you've got a slightly different data set that you'll be doing for your assignment, but this is basically what your assignment is. We're looking at, and this is not true necessarily, I forget what, I'm pretty sure that you're using a different data set, so this assignment, what I'm showing you today is exactly what your assignment is, it's just with a different data set, okay? So you follow, each of the steps is exactly the same. So for your assignment, and I apologize, this says essay, oh, it is essay 2. You're gonna have to state a research question just based on the variables that are there. And remember, this is all posted under assignments, okay? One variable, this is, well, it's longitudinal data, but just, I think for the data set you have for your assignment, it's not longitudinal. It's a pilot study that Linda Rohr and I did some years ago, the same sort of thing. And so you just pick any 2 variables. Obviously, when you have cross-sectional data, it doesn't really matter. It's just which variables you pick. It's just what your research question is. For example, you could look at how does activity restriction impact depression, or you could look at how does depression impact activity restriction. It doesn't matter. It's not, you're not really looking at causation. One of your variables has to be a composite score. Composite means that you have had to calculate it. So I'll show you how to do this. It means that you're going to have to, there's instructions for how to calculate the scores. You're going to have to like add up a variable. Okay, that's what a composite means. It's been calculated, and by the way, it doesn't have to be summed. Sometimes composite scores are, well, composite means summed, but it could be like that it's a multiplied score. And what variable names that you're using. So what we're looking at today is activity restriction in sports and recreation associated with. Is it associated with depression among unpaid caregivers? Notice I'm just picking one. There was there was 9 different activity restriction items. I'm just picking one little item. The first thing that we have to do is to clean our data. So I'm just going to show you quickly how you would clean data. I do it really quickly. This is the most important part of any study because it's very easy for humans to make a mistake when you enter data, okay? As an example, well, let me see. Like when you can see like a very common one, for example, is like it's supposed to be a 9, but people put a 0, like ones that are really close together. This happens with grades. Remember, that's why you should check your grades too. Even now, the great thing about online surveys is it doesn't do that. But you guys in the labs, you collect the data in the lab. It poops it out in an Excel file, is that correct? No one knows.
Not
always, okay. Then you guys put it in an Excel file from there. Then you take that Excel file and you put it into SPSS. There's lots of room for errors there, right? Lots of times people could make a mistake. So it's important to look at your data. Okay, so what we're going to do now is you go to Analyze, Descriptives, Frequencies, and Melissa, this is one thing I have no idea how you do this to clean data in R. Okay. All right. Because it doesn't look like this. Oh, it did. Yeah. Dan is so cheapo. Sorry, I don't mean to be like this. But he's like, that book was $120. I'm like, that's cheap for a book. Don't you think? I don't know. Like, I'm thinking like, anyway, Dan thinks it's highway robbery. And so if the guy put like a lot of work into it, I don't think it's really that. I don't think 120 for a book is that expensive. Anyway, most stats books, like my husband would be paying $500 for a book, like real stats books. $500. We would go poor. You guys shouldn't even have to buy. By the way, all you have to do is get onto, if you become a teacher, and then you can pretend you're a teacher, and you order the copy of the book. And you can just ask, you can ask any of your profs to order a copy of the book through the publisher to see if they want to use it for a class. Then they don't use it for the class, and you keep it. This is how it works. It's the best part of being a prof. Now, I'm going to now, notice, do you see how I'm able, you can highlight them and put them one at a time, like this. That takes a long time. Rather, notice that I am pushing down the control key, and if I push the shift 2, I can then select a whole bunch of variables at a time. Forgot to put Ken in here. I'm now going to just use the CESD. That's the activity restriction 8. Is that right? 7. 7. Perfect. Thank you. And then I'm gonna put all of the depression ones, there's 20. So you see, you can do that quite easily. Under statistics, you'll see there's various things you can get. You can get skewness and kurtosis and all that, but I'll show you some of that after. I just want to do frequencies first. And kurtosis, there's lots of things, but we really just want histograms. So I'll pick histogram and I want the frequency chart. I'm not running anything yet. I just want to show you what a syntax file is. So I'm going to paste this right now. See this word paste? Yeah, if you need to come up. Now it has pasted the code into the syntax file. It's called syntax1. Syntax, if you notice, each of these things has a different file name. Your data file is called a SAV.
Are they separate entities? Or
They're separate entities, yep. Data files are SAVs. Output files are SPVs. And a syntax file is something else with an S, and I can't remember right now, okay? Now, I could now save this file. I'd save this, and I'd call it exploring the data. I'd call my output file exploring the data. That way, if I need to go back to that, I've got it all organized. I also date my stuff with the date in it, okay? Because if you don't change the name, it means for example, output files will just be called output 1 or output 2. If you do that for your thesis then, and you save all of those and never change the name, you are going to have 54 output 1 files, okay? And you're not going to know what they are. So it's annoying. It's all about management. So this is the code. Now I could go back into Analyze. I could also just highlight this and push the green arrow, run selection. And it will now take a while, okay? And there we go. So you can follow along with this exactly here so that you guys can see better. Now, I have a trained eye, so I just skim stuff really easily. And look, I can see the mistakes. But you would want to look at this, really closely. But for example, when we get to date of birth, you'll see on your sheet here, I've got someone who's 98, like a 98. And that's because we know that respondents couldn't have been born in 1998 because I did the study before 1998, okay? So the reason is that probably that's a miscode, and that was supposed to be a missing data point, okay? You'll also notice I gave a tip in your first assignment. I personally don't use 2 digits for missing. I use 999, triple. Why? Because I work with older adults. If I haven't used 99, someone could actually be 99. So it's best to pick something that's, different. So what would I do? I would find the person now. I would go back to my file, my SPSS file, pardon me. I would go to data view. I could highlight the column now. I'm now going to do Control F, find who's 98. Person's right here. I see that they're case 120 or 1023. I would now go into the actual survey, pull it out, and say, oh, I miscoded something, and now change that and make the correction. Okay, so for our purposes, I'm just going to call this 999. It's missing. Older adults don't actually, that's a common, well, age is, people usually will say their age. The thing that a lot of people don't want to ever report, especially older adults, is income. There's usually a lot of missing. They think it's rude. It probably is kind of rude to ask. Now I go back to the next one. So, and I keep, looking down. I see that looks good. Ethnic. I would keep going down, and then I would see For example, where am I going to see a mistake? Here, sports and recreation, activity restriction. I have a 5. My scale goes from 0, 1, 2, 3, and 4. I can't have a 5. So I would go find that variable, and I'm not going to keep, but you see what you're doing? You go back, find the variable, figure out why is that a 5, clean that up. And you keep doing this until you've got all of your data, okay? And make sure that, see, there's other examples here. You can read through them. You'll see that I personally use find and replace to find my mistakes. It's the easiest way, like just highlight, Control F, and then you can find the weird data point really easily. In your world, you're not going to be looking for coding errors. You're going to be looking for some weird data point. If almost all the data range between, let's say, 60 and 120, and then you've got this one data point that's 325, well, that's weird. So you want to go and like find out, what was that? Was it, did you record it wrong? Was there an error with the machine? There could have been a surge, or I don't know. Someone turned the machine off. Could be you were out late and too late that night, and when you came in to collect data, yeah, don't drink and collect data. It's like, it doesn't mix well. So you would look at all these different things. Now we want to calculate a variable. So I'm just saying, you clean. So again, I'm explaining what I want to stress here is that you need to, it's very, very important to do this cleaning step. If you don't clean your data really well, then everything else you do is garbage. Okay, you have to really look at it and get to know the data. And you should never trust anyone. Okay, just because Dwayne and put the data in doesn't mean Dwayne is God and doesn't make mistakes, right? I think he is. No. But everyone, you know, it's really easy to make a mistake. So we have to calculate a variable. So we're looking at some sociodemographics, because one of the parts of your assignment is you have to describe the sample. So just their sociodemographics. And I need to calculate a variable. So you'll see one of your variables has to be composite. I'm going, for this class, we're going to calculate depression score, which means I have to add up DSD 101 all the way to 120, okay? And so to do that, I'm going to show you the hardest way. It's not how I would actually do it, but I'm not going to show you how to code in syntax. So to compute a variable, you go transform compute, and this is, if you look on page 2, I've got this whole diagram, how to do this, okay? Last year, 500 people, which was, the class was only 10 people emailed me wondering why. I remember Maria was one. I have no idea how to compute a variable. Turn to page 2 of the handout. Like, come on, it's right here. Every single person was coming in my door. Like, anyway, you guys, if you don't learn this from me yet, I'm very, like, have it all written. This was so that you guys, it helps you. And I admit, I started doing this also so people wouldn't come talk to me as much. Okay, I admit it. But first read my material, then come. Like, you can come and still talk to me every single week, but I'm gonna roll my eyes if it's something that is written down, okay? Maria gave herself the Dum Dum Award, I even remember that. So compute a variable. I now am going to call this a name, so I'll call this depression time 1. By the way, I don't show this here, but you can click on type and label, and right in here, I could, do I have this variable calculated? Sorry guys, I just have to check something. Yeah. I do. Just gonna delete that. I shouldn't have had that. Okay. Computer variable, expression, time 1. Couple things about adding. I think I explained this. It used to be that SPSS could only hold 8 characters. Okay, that's why people traditionally still use 8 characters. It's just out of habit. They can be longer though now. Also, it used to be that SPSS couldn't have a space. It can now. I still don't ever put a space. I like to use an underscore. I don't know why. There's no reason for it. It's just like what you learned, right? Now to do this, I would find I'm going to show you another little tip. Instead of scrolling down, I can type CESD and it jumps to it. Okay, I'm not scrolling. I just push a C. It's going to jump to the next C in the data. And now what we would do is we have to actually, put in every single one of these. Now I can do it a faster. Oh, no, I can't do faster way. Okay, I would type, you see what I'm doing now? I'm not going to go through this all, okay? Go all the way and put every single one in. I would also double check that I actually added all 20 of them, because that's really easy to make a mistake. You can't have no wine when you're doing this type of thing. You must be methodical, okay? You can't be distracted. I know this sounds weird, but I have tried to watch TV, doing data analysis, thinking it will be fun. It's not fun, because you end up redoing all of it because you made so many mistakes.
When you compute them, is it always just purely additive? Like there's no
In the assignment, you'll see that motivation is the fanciest one, and you add some up and then multiply it by something.
So then when we're computing that, do we need to utilize brackets properly or?
Yep. Okay. So for example, if I wanted, I would it's just like your BEDMAS stuff. So I would just go times 3. Okay. There's all this function stuff, just like in Excel too, that you can pull them up and use all that. I find it easier just to type it. Okay. So I'm saying I'm not going to actually do this now. I'm just going to pretend I did it, and now I have to undo my delete. Okay. So now I've got all of my variables. I've computed a variable. I have labeled it, etc. So now step 2 of our assignment is we have to describe the sample. Discuss frequencies, means, standard deviation, etc. of selected socio-demographic variables. So we are going to now go back to our data set, and I'm just going to say analyze, and we're going to use the explore. I personally so frequencies will give you just frequencies, but you can also get some means and stuff. Descriptives will give you your descriptive stats, but you don't get the frequency table. Explore gives you lots more options, and you can also explore by group. For example, I could say, I want all the descriptives, and I want you to factor it by gender. So I'd first get all the descriptives for females, and then all the descriptives for males. So there's different ways. Explore is, I don't know, it's the best feature. So in this case, I wanted, I don't even know what I said. I'm just putting in my various socio-demographics that I have. I put them in the dependent. In the factor list, this is where I could do a grouping. I could do it by, I could get them by gender. I could do it by condition, like for treatment, the type, if you're doing repeated measures. There's various statistics in here. We just need descriptors right now. You can also get plots, histogram. You can get normality plots. We don't really need this stuff though right now. And options, it's just list-wise or pair-wise. So I just want to explain what those mean. Listwise means that it's only going to show us data for participants who have complete data on every single variable that we put in. So for example, what if Betty didn't report her age, and that was one of the variables we have in here, Betty won't get counted at all, even because she has missing data on this one variable. You might not want that. Maybe you don't care about missing data. In that case, you do what's called pairwise. Pairwise means it's only if they're comparing two things. It's going to just give the n for each variable how it is. So I like, when you're exploring your data, it's better to say pairwise at first because you want to see what each one is individually. So here I would get all my stuff. You get your descriptives. We're not as worried about that. And I then come down here. Where is it? Do you know what? I shouldn't have done that. I should have done. I'm sorry. We're going to explore, but we just want to explore our to be able to do our sample size. Sorry, guys. Well, I'm just gonna say, okay, it doesn't matter. All right, so I'm just gonna look at some frequencies, and I did it wrong again. One more time. Statistics. I want the mean, and I want the standard deviation, and frequency. So I go through here. Now we got it. Now, when I look at this, then I want to look at a frequency table so that I can say something about the people. So let's just look at this one. Does the caregiver have dementia? It's yes or no. So when you're describing a sample, notice it says frequency. It also has percent, and it has this other column called valid percent. The valid percent doesn't include people who have missing data. It's better to report the valid percent when you're doing descriptives, okay? Because it gets rid of the missing. So in this case, I would say that 58.8% of the sample reported that their caregiver did not have Alzheimer's. In my description, you'll notice, I'm not telling the reader who said yes. Why? I'm not saying 58.8% said no and 41.2% said yes. Why would I only put one or the other in a little write-up? Another example. In your example, I have sex. I say in my example I've got for you guys to read, I say 77% of the sample were female. I don't say anything about males. Is that because I don't care about males? It's obvious. It's obvious. Yeah. You have to save space in your writing. If there's 77 males, or females, then you know that there's, 23% are male. So when you're writing a journal article, you don't have time, you don't have enough space to write every bloody thing. So you just pick a few highlights. Another example is for marital status. In my example, I've got, most of them were married, okay? So I'm just going to say 67.7 were married. Or here's education. I'm not going to say what every single education level is. That's too much. So in this case, I think I said, I add these all up, and I said that at least, let's say 20, well, I'm just pretending I know this math. Looks like 43 or something. 43% of the sample had at least some post-secondary education or higher. So you're adding up a whole bunch of the categories together. Okay? Now, my trick for this is you'll notice that I told you have to report means and standard deviations. What type of variables can you report means for? For example, 100% every year I get someone that says to me, someone will write in their paper the mean for gender. They're going to say, one of you guys is going to do this. Hopefully you're listening, so you won't. Someone's going to say to me, in this sample, the mean of gender was 1.23. Why is that ridiculous?
22 male or female.
Right. Gender is a nominal variable. So you can't get means or standard deviations if a variable is nominal or ordinal, if it's a category. You can only do that for interval or ratio or scale variables. Okay? And every single year, when one of my grad students also comes in, and they've written up their whole stat section, and the whole thing is filled with all the means for income categories and everything, and I roll my eyes. Okay? So think about it. You have to think about it. Just because SPSS will spit out anything, you have to think about it, right? Not, it's just a computer. So, in your assignment, you will write up something about the sample. And you can use some very similar to what I have here. So, I said mean caregiver age was 62.8. How did I figure that out? Well, I took age, I subtracted what the year was of the study, and then I computed a new variable to get age. That's how I figured that out. I'm not saying you have to. Again, I'm saying most of them are Caucasian. They're highly educated. Well, there you go. My math was bad. 60% were about had some university or college. I say what the household income was, categories, and yada yada yada. So I'm just pointing out a few things. Step 3, you need to run histograms and talk about skewness and kurtosis and the Kolmogorov-Smirnov test. Aha. Now, in this class, I've always called it the Russian vodka test. But then I heard in the halls, Fabienne's talking to Dwayne, and they're saying, did you do the Russian vodka test? Oh, I forgot to do the Russian vodka test. And I'm like, oh my God, we sound like real fools in HKR. So why did I call it the Russian vodka? Because it's like, people like, obviously this is a name, Russian. Smirnoff is a vodka company, okay, for people who might not know. And so now, so that we don't sound like total idiots, and we're talking about leptocurtic and all this kind of stuff, right? I now call it the KS test, okay? But just so you know, around here, you might hear it called the Russian vodka, but we say KS now so that we sound a little more sophisticated. Okay. By the way, why is it called this? Interesting. This guy invented the test. This guy also invented the test on another part, and they published it in 2 journals at the same time. So they said, hey, we both did this, so that's why it's hyphenated. They weren't a team. They both invented it at the same time in history, so they call it that. So you have to look at a histogram and look at the distribution. Look for outliers. Outliers are scores that are different from the rest. They're weirdos. Okay? Whoever is the weirdo, they have low, very low, or very high scores. Outliers can bias the mean, and inflate the standard deviation. And sometimes you remove an outlier. If someone is too weird, you take them out of your data, but you have to say that. Why? For example, I don't know. It's not gonna happen. Someone might have an abnormally low resting heart rate or something. I don't know what I'm talking about, but something that's really weird and it makes all the data look different. So you might do that. And we also have to look at, so for example, this is what I get for, actually I'll show you. You guys are all antsy. Go to the bathroom, everyone take a break. Sorry. I can see I'm losing everyone, so. Are you?
Yeah.
I'm really cold in here. It is hot.
Frigid.
I'm walking, and I also have my maternity. Well, I'm trying to buy. I can't be. You don't need half. Don't make. I mean, if this ever happens to you, don't buy all that stuff. It's ridiculous.
That's your futures, because I'm gonna buy all the maternity clothes.
Oh dear, I'm just not that kind of girl. That's not.
Not what it says, $5.
I bought, like, I had 2 outfits that looked nice. And that's it.
Yeah, sorry.
You should see my pants at the end. I bought extra, extra large from Piper's men's.
The most comfortable you can get.
Yeah. I'm not really fashionable person.
Can I ask you?
Yes. Yeah, it's really
Where?
You know, in measurement, you put
You want me to look at SPSS?
Yeah.
Okay.
in
And variable view, okay.
For ID, you put SK. But in the video
Oh,
that is
Yeah, it's just because I wouldn't, who cares what it is for ID?
Okay.
Like, it's just it's just the name. Yeah.
Okay.
It doesn't, I mean, I could have put, I guess technically it would be, well, see, it's not really it's nothing really. It's
Oh,
just
it's not
like to
important.
keep track. Yeah.
Something else about the missing value. I did something here in the data view.
Yep.
I go to the, if I'm not drawing in the transform.
Yep.
And there's a section to
For missing data. Yes.
missing data. But for the last assignment, we have 3: one missing
Yep.
value, one unknown, and something else I cannot remember.
Yeah, like don't know and all that. Yep.
Yeah, but we can just add 2 items. Just for example, 999 or 888.
Yep.
I cannot add another option, and so it makes me to add another option by hand.
Like in here, you mean?
Yeah. It's set the data, for example, 999 automatically. All missing data
Yep.
change to 999.
Oh, that's what you did.
Yeah.
Okay.
Automatically change all
Okay.
missing data to.
You can do that. The reason I didn't want you to do that for this assignment though is because there's different reasons why you care about why the data was missing. Sometimes you want to know if someone didn't know. Sometimes you want to know that they just didn't answer it, or it could be like that it's just totally missing and like the researcher has made a mistake. So sometimes you want to understand why the missing, like that's why you put 999 or 888. Sometimes you don't, and you're right. You can go into that variable thing and just say make all of it. Yes, but it depends on your study.
Select, for example, column row 1, 2, 3. Just change row 1, 2, 3.
Oh, okay.
In 999, and rest of them to 888, for example.
Okay,
But you can just choose 2.
just to two. Well, no one would do it that way though. Yes, yeah, no one would go in there to.
Even I have to check it.
No one, if you were going to use that thing that you're talking about, this, okay, that would be more like when someone doesn't code anything. And for example, this is what, if you don't put something in, see, this is missing right here, okay? and it's called system missing. It's just a dot to show there's no data. This, I could easily do that, like what you said, and then I can make all these dots be 999.
Mhm.
No one would use this missing thingy, okay, if they cared about the 999 and the 888 and the 77. They would, it depends on what, when you're dealing with like survey research, you care why they don't answer. In XFIZ though, you wouldn't care. You would just say, oh, I have all this missing. I'm just gonna use this.
Oh, got it.
Yeah.
One else, just for a moment. And then quiz 3.
Yep.
You know, there was a question.
Yeah. So what do you usually program for, like cardio and weight training? Or?
Yeah.
Oh, okay.
I use the.
Okay.
So this is a good idea. Yep.
I put ratio, but not in the book and in your PowerPoint, both mark that interval and ratio both together. But I just checked the ratio by chance because I cannot understand why it might be interval. Why not?
The minimum level. So that means that I could do a Pearson correlation if I have interval, and I can do it as ratio. Ratio is a higher. Yeah, you're just getting mixed up by I think the English of it. Okay. So I'm saying, what is the minimum level? So you can do it with interval and you can do it with ratio. So interval would be the minimum. Yeah. Like maybe I should have that to say interval / ratio. Yeah. Okay. Does that make sense? Do you understand?
Yeah,
Oh,
I
okay.
understand because
Okay.
you know I read the book and both
Yeah.
ratio and interval, and I cannot separate it because you know everywhere is mentioned that
It's interval
Pearson is
/ yes. So it's a question, it's kind of a trick question to see if you understood that it could be interval and ratio.
differences. Okay.
Yeah.
Okay, thank you so much.
That's a good idea to take a picture with your questions.
Yeah.
Yeah.
Because I want to
Yeah.
check.
That's a good idea.
Thank you so much.
Yeah, it sounds good.
Okay, are we up?
Yeah.
I don't think I'm gonna get through everything. I'm too tired.
Doing good
Yeah.
exercises.
Am I supposed to do correlations too today? Yeah, okay. There we go.
So today's lecture is gonna be available like.
Oh. Sorry, Josh, we are pausing right now and having a break, but you're still on. He can't see me. Anyway, yes, I will, assuming it works. So yeah, both showed me how you can do that in your own YouTube site. But you have to have the creator thing enabled, and it's really hard to figure out how to get into it. I don't know how to explain it, but I had to like, as an example, it took me an hour to figure out, and then I kept the tab open for the whole day so that I didn't close it, okay? Because I don't know if I'll be able to figure it out again. And all the other websites said like download all this stuff, but you don't need to. So for example, I can now, one class I'm gonna miss, or for my undergrad class or list, I don't have to miss it. I can just like, this weekend I'm just gonna do the very basics of the lecture, and then they can watch it at home. How was TA's talk last week? Good.
Very good.
It wasn't Everest.
It's always like very inspiring, like even if she's talking about like going to the bathroom, it's very.
Going to the bathroom.
Like I went to the bathroom, and it's so important that you do, just how she talks is very methodical. It makes me want to go to the bathroom more.
All right. So we're now going to look at how do we just explore our main variables that we're interested in. So we're going to go to explore, analyze, descriptives, explore. I'm resetting this. Okay. My variables that are of interest to me right now are, it's ARS 107, which I just did ARS. So one item, and then I'm also interested in the one that I calculated, depression time 1. Please note that the values that you see on the screen are going to be slightly different from what you see in the handout because the handout is with clean data, okay? I didn't bother to clean it. So, statistics, I want outliers and descriptives. And notice when you go home and you forget how to do this, what are you going to do? Look at the sheet. You're going to look at the sheet and it says which box, right? It says everything right on here. It's funny, I don't know how many times every couple months I get an email from one of your profs. Could you please give me your handout for repeated measures or then I think, and I don't ever say this to them, like, could you not have saved the handout like the last time? You know. Remember to download all of this stuff that's on D12 website. In a year, you're going to come to me and you're going to say, I really want a refresher on these notes. Could you, a couple people asked me this one, can you please give me all of the handouts from 6000? Like, I don't have it like that, okay? So make sure that you download everything. You're going to use this stuff in your life, maybe. If you end up teaching, just make sure you cite me. You're welcome to use it though. Plots. I don't care about a stem leaf. I like a histogram. And I also want a normality plot with tests. Options, this is listwise or pairwise. Okay, I'm just going to keep it listwise, but I would actually probably normally do pairwise actually, but bootstrapping, I don't know if you guys even have Bootstrap. Depends on your version. My pirated illegal version is better than the university one. So university doesn't pay for bootstrapping. Bootstrapping is if you don't have normally distributed data, it helps to distribute it. It transforms it. If you want to play around with it, you can. But by the way, it takes sometimes half an hour. Okay, like you click that, you go buy a coffee, you come back. Okay, SPSS can crash your computer. Really, if you have too many things open, like don't have. Well, okay, I've got a really good computer, but like, if many of you don't have very good computers, so you can't have like 5 PowerPoints and 10 words and all this stuff open. Like it'll.
It drains your battery a lot too.
Yeah.
More than else.
Because it's processing on it, right? And it depends on what drive you've got. If you've got this thingy or you've got the SSD, right? That's why SSD is. That's what this. Yeah, this is some kind of Tetra gig SSD. I don't even know what it is, but anyway, it's supposed to be able to run Fuller type data. That's actually what I asked for. Fuller type data. All right, now I push, okay. So, by the way, this is what you would save as your output for your assignment. So I would save this file now as, Angela essay 1. Okay? Why do I want you to put your name on it? I do not want 10, 6,000 essay 1s, right? Like I don't know I need to know your name with it. So, right? We now would quickly we look at this then to see different things. So I think I forgot to tell you, I need to go back to our diagram. I'm gonna show you. So the histogram tells us, obviously, some information. So here, for example, I look at this. It doesn't look very normally distributed to me. It's also really hard to care. Look, it's only on a 0 to 4 scale. It's really an interval level data, so we don't expect it to follow the normal distribution very well. But it looks like it has a positive skew, and that's because the mode is 1. In this one, I look at this and I see, well, okay, let's see if anyone can answer this without looking at their sheet. Is this positive or negatively skewed? Positively skewed, okay? So most people, the majority of people don't have depression. I think what this was, anyone over 20 has severe depression. I also look at this and see, ooh, there's some pretty clinically depressed individuals too, right? These are outliers, but there's some people with very high depression levels. So I would say that it's positively skewed, and the histogram kind of shows there's some outliers.
If you've got an outlier like that, do
Yep.
you refer them on to additional resources, or is that within, like, if you see someone that's like, oh wow, like you're very obviously clinically depressed, maybe they haven't seen help with you do anything about it?
Oh, good question. This is an ethics question.
Yeah.
Okay. All right. At first I was like, do you do anything about it? Well, it depends on your analysis. No, but I understand. So Melissa's asking, like, you're a researcher, you just collected this data, and you see that you have 2 people who are extremely depressed, right? Like, this is, you're concerned for them.
Mhm.
What do? Well, you have to think about that beforehand, and it's an ethics. Most of the time, people don't do anything about it, okay? I didn't either, I will admit, okay? But you could look the person up and do all that, but you would have to put that in ethics that you would do that. Right. And you could then mail them some materials, okay? Depends on your study. If you're working with medical professionals, I would tell the medical, maybe they can talk to their doctor or something. The only thing we did in this study was we trained our interviewers, so it was a structured it's not a qualitative interview, it's just answering the survey, but with a person. We trained our interviewers to look for elder abuse, because that's very common. People like physically hurting and psychologically hurting the person that they're caring for, or stealing their money is a common one. And we would also double check, and also it can happen the other way. Sometimes the person with dementia can be physically abusive to the caregiver, right? So we looked for abuse, and it was actually in our consent that I would say that if there were signs of it, if we saw signs of abuse at all going on, and I made notes we made note if we thought the place was dirty and stuff like that, the environment, then in the States we had to, it's different from here, we had to legally report that because they're a vulnerable population, okay? With children, if you're a researcher and you see something with a child, you legally have to report. You might legally have to report child abuse. Okay, so you would say something. But that's a good question. You and firstly you see it's kind of sad that it comes up more than you think. We have to think about skewness and kurtosis. I'm just going to quickly explain that to you. So this is our standard normal distribution. Standard means it's standardized. Why do we do this? So you guys probably you might not remember this, but back in undergrad stats, your favorite thing was calculating Z-scores, right? Everyone loves it. So fun. Funny story, when my husband taught in the States, his TA came up to him and said, none of the students understood what I was saying to you because they said, oh yeah, Mohammed, I told them the story. They said, Mr. Atkinson talks about Z scores, and you're talking about Z scores. We never learned Z scores. So anyway, I say Z. So why do we do this? Because it's a way of comparing things. So when you standardize something, it allows you to compare it across everything. So think of it, all your variables that you collect are measured on a different scale. Standardizing allows you, instead of having apples and oranges, to be able to make them the same and have fruit. Okay, it makes it the same. So here we know, theoretically, that 99.9% of the data will be 3 standard deviations away. 95 should be 2, and 68 will be 1 standard deviation away. So, and obviously data is never going to have a mean of 0 and a standard deviation of 1 though. So we have to calculate it. So this is what a Z score is. It's taking the mean and the standard deviation and converting it to follow the standardized normal Z distribution. And you guys know probably how to do this. What proportion, so you can then see, for example, if your Z score is 1.4, it means that is the, it's the percentage then of that score being, how many are less than or equal to that. We can use Z scores then to compare and think of things. If we have a Z score that is plus or minus 1.96, it means that 95% of the values should be within that range. If it's 2.58, it means that 99%. If it's 3.29, it's 99.9. And that is why, you'll understand in a second, when we look at skewness scores, we convert them to a Z score, and it means that if any Z score is over, we use a rule of thumb of 1.9, not 1. Usually say 1.9, not 1.96. If it's greater than 1.96, it means that it is statistically significant. Okay? So a rule of thumb when we look at skewness and kurtosis Z scores is that anything that is greater than that will be significant. You'll understand in just a second more. Skewness and kurtosis. So skewness, the score for skewness that you get out of SPSS, it tells you something. If it's positive number, it's positively skewed. If it's a negative number, it means it's negatively skewed. Pretty easy. Okay? And the thing is that SPSS gives you a skewness score. You can't compare an apple skewness score to an orange's skewness score. So we have to make them to be Z scores so we can compare them across. So we use the rule of thumb that a standardized score that's greater than 1.96 must be statistically significant. So we expect that about 5% of the scores would be greater than 1.96. Kurtosis, same thing, it's a little different though. A positive value means it's leptokurtic, okay? Negative means it's a plateau, platykurtic. And again, if the Z skewness score is positive, is greater than 1.96, it's statistically significant. So here's the output for sports and recreation, or ARS 107. If you turn to this page, this is where I am. Okay. So all we have to do is we find these values here. We have the statistic and we have its standard error. To determine whether what those values are, we simply take our statistic and we divide it by its standard error. And then we would get a Z skewness score. Here, we take the kurtosis value divided by its standard error, and we get the standardized kurtosis score. I just copy this, stick it in Excel, and go blue, 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 like 3 seconds, okay? It doesn't take long. So in this case, you'll see that in this write-up, I end up with what do I get? I get 2.43 is the skewness. 2.43 is way bigger than 1.98. That means that it is statistically significantly skewed. If that value was less than 1.98, no skewness, okay? It's okay. Kurtosis, I would do the same thing. In this case, what's the value I get? I get, I don't know what I get. I don't have it written down. Well, anyway, divide that, it's negative, by the way, so negative means that it's platycurctic, and I would get a certain value then.
What's the purpose of the 5% trim mean?
Where you, oh. Nothing. Well, no one, I've never used it. But, and I'm going to look, I'm not going to, what would it be? Well, my guess is that it's saying that if it's giving you a 95% confidence interval, my guess is that it's giving the mean for the people that are out of the, yeah. Good question. I don't know the answer to it. I've never used it. I've pretty much used everything on there except I've never used that one.
I've never seen it before. That's why.
Yeah, that's a good question. Okay, so we now know something about the distribution. We've actually calculated the skewness and kurtosis scores.
You're right about that, Shannon.
You just Googled it?
Yeah.
What is the again? Sorry?
It's like, well, based on like a 10%.
It's the mean for the people who are outside of the confidence. Yep. Okay. We also want to look at our outliers. To look at outliers, we look at box plots. So this is a box plot. The dark line is the mean, okay? Then you have certain block that shows, actually, if you think about this, I know you might not notice this, but let's just see. I want you to, this is depression. Okay, just a second. Okay, here's depression. You're staring at this from here, right? We're looking at it as if we're looking out at a scene, okay? A box plot is just an aerial view. Notice I'm up top now. I'm up in an airplane looking down at my distribution. I can see the clump here of how all these people who were not without depression. You can see how we had then the long thin tail that was sweeping out. So these are called whiskers, and the whiskers tell you the spread from around the main clump of where your data is. And then SPSS gives you, you don't even have to do this, it poops out the outliers for you. Notice it gives you, it only, by the way, SPSS won't show you all of them, it just gives you the top 6. You have to kind of look at them as well. And the numbers that it has here is like 229. That's the case number. Person 229 in the data is that person that we're really worried about, that might have, might be suicidal even, okay? So we can then look then, who are these weirdos or these outliers? So this tells me then that it indicates that, I didn't say this, the tinted area, like the brown, part, that's where 50% of the data lies. 50%. The median is the dark line, and then you can see your outliers. So you can see how it's not normally distributed, and there's a lot of outliers. So you don't just tell me that there are outliers. I want to know what kind of outliers. In this case, I would say there are several outliers for people with very high depression. You don't have to tell me who they are and everything, but don't just say there's outliers. I want to know, were they high or were they low on the variable? Now, here's our activity restriction. Now, it's only 5 categories, so it's not the greatest variable, but kind of looks sort of like what the histogram looked. And we can see here that, you know, in this case, it kind of looks normally distributed. It almost looks, you know, like, or we could fold this over and it would match pretty close. There's no outliers. We would, on a 5-point scale, you're not going to have outliers anyway, but, you know. So we can also use z-scores for outliers. I'm not expecting you to do this. I just want you to look at the box plots. But you can calculate this. And there's statistics that you can do in SPSS to figure this out. So we would expect that at least 5, we would expect to have around 5%, or I mean less than 5% outliers. So Melissa, for example, you're going to do this. You're going to have to do this in your data. And usually in regression, remove the outliers. If you have, like, assuming you have a very large data set. Yeah. So you get rid of anyone who's an outlier that's statistically significant. Okay? By the way, you have to record this. When you write this, you say, there were 5 outliers who had very high scores of depression. These people were removed from the data set from further analysis. Okay, you have to document it. I've seen in XFIS world, people will remove outliers and then just pretend that their N was 1 less. Okay? It's kind of lying. Not kind of. But I don't think they mean to lie. But you need to say that. You need to say, we had an N of 16. 2 people were Olympic athletes, and so their MVCs were crazy, and thus they were removed from the data set.
Would you want to do that though? Like, is it necessary to remove it?
It only depends. It totally depends on what kind of stats you're doing and what your research question. If you're doing regression, you have to remove them. But for like repeated measures ANOVA, you don't care because they're their own control group. But if you were comparing that Olympic athlete to someone else, you can't. You would remove them.
I don't think I've ever seen any of our literature that come from the lab like, hey, this was removed.
It's mostly because they don't say anything.
Yeah. Yeah,
Okay.
That's probably exactly.
Like, they won't even say like 2 people dropped out of the study. Like they just kind of, they don't talk about, they only talk about what they analyzed.
Right.
But that's actually, it's not.
No.
It's not awful, but it's not being honest. Like you're supposed to
Not
say.
like reporting it would give it any less validity or something like that.
Well, reporting it is important because it says something like, if half your people dropped out of your study,
That's something wrong.
it says something, yes. Okay, that's why they don't say it, because it makes, most people don't write up anything that they think might make someone question something.
But it's interesting. I've seen, you know, what's her name? And oh my God, does all the down here. Michelle Plowman.
Okay, yeah, that ding, yep. Yeah.
She just released a study while I was on the news. I don't know if you've seen it.
I don't,
And I was talking about like this treatment for MS.
okay, yeah.
So like they was saying, oh, this is really good treatment. Exercising in a cold environment.
Yeah.
8 out of 10 participants finished the study. Like,
Yeah.
8 out of 10, but that's 20%, like, that didn't finish the study, if you think about it in that respect. So, like, what kind of validity is, you know?
Yeah, excellent point, and I agree with that. It does pull out things in question. In this case, though, like, when it's those types of specialist populations, they don't care about that as much because it's pretty hard to get anyone with MS to like do the study in the first place.
Yeah.
Okay.
That's what I was wondering, like, is, you know, does it take away from the study at all, or, you know, 2 people didn't finish? She only had 10 participants.
It kind of does, yeah. But, she reported it then, right?
Yeah, exactly, that was on the news, like, that. I don't know what if she actually had the study published at this point, or if it was, you know.
Yeah, because they were doing like a cold water aqua.
Well, this was in
water?
cold water, it was cold environment, and it
Oh.
looked like it was suspended travel training.
Okay. Because she does stuff with, well, lots of people here. What do you do with alerts, by the way? So it depends on your thing. You can remove the case. You can transform the data using like bootstrapping. Some people will change the score. I don't think that's a good thing to do. Okay? Sometimes people will use the average across the participants and put that in, so they don't have. I don't like that, but there's sometimes reason for it. So you would do that. Now, next thing you need to know is how are we going to know if it's normally distributed? Well, we looked at our histograms. We've checked if our Z scores if our skewness and kurtosis are statistically significant, but we still don't totally know. So it doesn't really tell you like how severe it is. So what we use is the KS test. There's also the Shapiro-Wilk test. And we're just using the KS test, but I'll tell you, next level up is that you actually should, it's a good idea to look at both of the tests and see if they say the same thing, which they usually do. But the KS test compares the scores in the sample to a pretend, like a made up sample that has the same mean and standard deviation. For this is important. We get so clued into that we want things to be significant, okay? But this is one of these tests, you don't want it to be significant. You hope that it's not significant, because that means if it's significant, it means that it's not normally distributed. Okay? So, if non-significant, then it's normally distributed. If it is significant, it is not normally distributed. Half of you, well, maybe not half, 1/3 of you are going to get this wrong on the exam. Okay, so pay attention on the exam, on the assignment. Pay attention to this. You have to keep doing this every single assignment. Half of you are going to forget this lesson halfway through the course, and you're going to report this wrong. Okay, so it's pretty easy. I mean, I don't know. I just, like, how can you not remember it? But, you know, just something, always double check on that. So, this is what you get in the output. So we've got two tests. And you can see that I have statistical significance, because in this case, P is greater than 0.10. So P is less than 0.001. The only p-values that we will report is these. Okay. So if in this case it means that we are 99.9% confident that those variables are not normally distributed. Does anyone know why I did not put p equals 0? It's actually a good idea. It's best practice, actually, to not use those symbols. It's actually best practice to report the exact p-value. Okay? In this case, though, I'm not putting p equals 0. Does anyone know why? Because it would imply that I was 100% confident in my results. And that is wrong. That's my biggest pet peeve. And many of your profs violate this. And basically, this is one of my tests. I know if someone actually understands statistics by if they say p equals 0. If they say p equals 0, it means they don't really understand anything about stats. Okay? Because that just means that SPSS, there is a 0 in here somewhere. There's a 2 or something. Okay? They're just not reporting. They're only giving 3 decimal places. If you say p equals 0, it means that you, like there's no error in your data. That's ridiculous. Okay? So, and by the way, all of, like Fabienne does this, Dwayne, I don't know if Kevin does, and Dave does too. Drives me crazy. But that's just, they don't care because their journals think it's okay. Okay? But if you want to really be impressive, you won't do that. So in this case, both of these are significant. It means that they are not normally distributed. Okay? So I have to write that up. And here's an example. Depression at time 1 was not normally distributed according to the KS test. The KS test uses a D symbol. Why? I have no idea, but that's just what it does. Okay? It's a capital. It is hyphenated, or it's italicized. I then, in brackets, in subscript, I have the degrees of freedom for the test. So this is telling me that 143 people were in the sample. I have a space, but in I hate it when, like, you can't, with stats, you have to put spaces, otherwise it's all smushy and hard to read, okay? It's important. So space, space. And then put my value. Now I'm saying P is less than 0.01. So you get all that. Well, this is just a little tipper. What do you do if your data isn't normally distributed? No, you guys aren't going to do this. But if I had really done this and I'm like, oh shit, it's not normally distributed. What do I do? Well, I can transform my data to correct for problems, and there's various transformations. One is bootstrapping. By the way, when I was in my stats classes with social science people, I was told that transforming data was lying, and that's not true. Okay, my stats people taught me wrong. In statistics, it's fine, but if one variable is not normally distributed, you can't just transform that one variable. It's not lying if as long as you transform the whole data set. If you do a transformation to one variable, you must do it to them all. Okay? That's the only rule. I was told it was fudging though. You also have to give the descriptive stats for your variables here. So point out that I don't care about the range, but we have a mean and standard error we want to report, as well as standard deviation. So in every assignment, I want a mean, I want the standard error, and I want the standard deviation. Most people just report standard deviation, like mean and standard deviation. Standard error is more important. Standard error tells you the error in your measure. You'll see this in my write-up. Here, I think I've got a tip on this. Walk with the chalk, really walk with it. Here it is. Okay, do I have this written? Second. Oh, okay. No. For a mean, I've got this written in one of the assignments anyway. But for your mean, the mean should be 1 decimal place, can't spell decimal, bigger than the level of measurement. Okay, what do I mean by that? Well, I measured this on a survey scale. It's a whole number. They put a 4, they put a 3, they put a 2. It's a whole number. How many decimal places are there in a whole number? None, okay? So my mean that I'm going to report then is 1 decimal place greater. So that means I will say 11.8. Okay, why do we do this? So another example, if I was measuring length, let's say measuring in, I'm using some machine, and the machine, the EMG machine, poops out 2 decimal places for the data. Okay, how many decimals then would I use for the mean? 3. Okay. Why do we do this? Because it's really silly, it's really dumb. I see this all the time. Like, so they measure number of jumps. How many jumps did someone do? And then they'll put 1, 2, 3, 4. Like, you can't be that accurate. That's like saying, I measured something with a meter stick, and now I'm going to give you the answer in millimeters. Okay? So you can only be so, like, you can't be this accurate. That's ridiculous. So you have to look at what, so in most of this class, the variables are whole numbers usually. So it's usually 1, okay? Now, in your world, you're gonna have your machines like EMG and all this stuff, and usually they spit out like, I think it's like 10 or more decimal places, right? Okay. So what do you guys do for your thesis? Well, I would just use, 2 or 3 decimal places. The other thing that you can do is often the journal that you are trying to publish in tells you how many decimal places they want. So you follow their rules, even if they are wrong, and don't follow my rule. Okay. For standard deviation and standard error, 2 decimal places. Okay, so I put what, 11.8? 11.8, so my standard deviation then will be 10.56, okay? 2 decimal, you always put 1 more decimal place than the mean for standard deviation and error. Yes, these are things that I look at. Yes, you will get your marks up if you don't have this correct, okay? Attention to detail. Now, by the way, the way I have it is I give you style marks on your assignments. At first, they're worth quite a bit, and they kind of, actually, sorry, they're worth more and more as it goes on. Jeff Power, I remember Jeff Power. Now, he's got a PhD and he's a prof now, he's a pretty smart guy, okay? He didn't give a shit about the style. He never corrected his stuff. He just handed in his shit stuff every week to me. He slept in class, and I'd ask him in class though, and he could always still answer the frickin' question. I could never catch him. I tried to catch him, like, okay, but he was so, it was like, I think he was kind of, and I was just mad at him because I felt like, so he would complain. I mean, I thought, like, if his class is too easy, then do something about it. Don't just, like, sleep. Anyway, he never cared about any of his stuff. Now, he has a PhD, but he did not do well on his assignments at the end. Like, so he was getting 70s on his assignments at the end of the term because it was absolutely perfect, but he didn't care. So looking at people, you must know him.
You should see his lecturing style.
Oh, is it bad?
It's a mess.
It's a mess. Anyway, he's a little, like, scattered. Anyway, it's a mess. I can't even picture him even talking in front of a class.
He's about an hour and he'd sit there and he'd identify the landmarks.
Well, You can do pretty good research.
Yeah, you can do research. Yeah, you just can't lecture.
Anyway, you can't sit in class either. So here's my example. On average, caregivers were slightly restricted. And I said that because of the scale. I'm kind of giving some information. I give my mean, 1 decimal place, standard error, standard deviation 2. I say the same stuff for depression. Notice that all my stuff is italicized. Why do we italicize statistical symbols? Does anyone know? You guys don't, your profs don't. But they should be italicized to make them visible from a normal M. It's easier for the reader to see it. Okay. I just wanted to show you that you could explore the data for 2 groups. You don't have to do this. I'm just going to show you. So here I'm going to do analyze, explore. I have all the same stuff. Now I'm going to go caregiver sex in my factor list. And now I will get all the same stuff, but it's going to, see, now it's got male and female divided, okay? It's really easy. So I find, like, I've seen students actually make different data sets for their males and their females because they don't know how to do the stats, right? They have 2 different data sets. You don't need to do that. SPSS allows you to group everything, compare everything. You can select certain people, filter. It does everything. If you want, I guess my point is, if you want to do something and you don't think SPS does it, it's not true. You just don't know that it does it. Okay, so you look, you come and ask someone, you look, like Google it, you'll find the answer. All right, we have 3 seconds now to do correlations, and we're not going to finish it. So I'm going to go fast, and I might have to finish this next week. You might be able to figure this out for yourself for the assignment, but don't, like, it's not, I'm not going to penalize you, like, just the assignment is due at the end of next week anyway, okay? So if we don't finish today, I will finish it next week, okay? And then you can have another day for your assignment. This should be review for a lot of you. I mean, it's not too much. A correlation is a measure of the linear relationship. There's only 3 ways we can say that they're positively correlated, negatively correlated, or no correlation. Just going to show you another symbol that people sometimes, I still walked with my chalk. Another way of saying this would be, you might have seen this. This is the math way of saying it. They're totally related. 1 over means that it's inversely related. So why do we measure relationships? We want to look at covariances. Variance is the average amount that the data varies from the mean. That's what variability means. We're looking at how much does all the different data vary around the mean. And for 2 variables, we want to know whether change in one variable is similar to the change in another. So this is what's in your textbook. Here, there was 5 different people, and 5 of them had a certain number of advertisements promoting candies, okay? And they measured how many packages of candies each person bought the next week after they had seen the advertisement. So, so packets, how many packets, and the advertisements. So they're looking to see if there's a relationship between how many ads a person saw and the number of packages bought. You're assuming that the more ads you saw, the more candies, I guess, would be the kind of thing. So, if there's, so we're looking, we want to see if there's a relationship then between these. So we would assume then one variable deviates from its mean and the other variable should deviate from the mean in the opposite direction. Okay? So for example, you can see here, this guy saw a lot of more ads. Looks like he bought the most candies, right? And they kind of look, each person's data point kind of looks like it's going in the direction that we would expect. But one of the problems when we look at covariances is covariance depends on the level of measurement that we use. So we can't say a covariance is particularly large or small unless they actually have measured these things in the same units. Okay? Again, if you've got apples and you've got oranges, you can't compare them. We need to make them fruit. Okay? So what do we do? Well, to convert a covariance into a standard unit, a standardized measure, we use a correlation. So these are all the same words. Standardized covariance, correlation coefficient, Pearson product moment correlation coefficient, Pearson correlation coefficient. They're actually all the same words. Okay? And that's what that means. So a correlation can vary between the value of -1 and +1. A value of 0 would imply what kind of correlation? None. Yeah. And generally speaking, this, by the way, is by Cohen, C-O-H-E-N. He's someone people cite when they reference, when they use correlation things. You'll find it in the field textbook. But if a correlation is around 0.1, that means it's pretty small. 0.3 is a medium correlation. 0.5 is large. Now here I'm saying effects, because a correlation is a form of an effect size. I want to also point out that this is in general. In exercise physiology, like this is what everyone else in the whole world cites. In XPhys, you're going to find that there's different ways of looking at correlations and effect sizes. And when you're dealing with human physiology, 0.5 is actually small-ish, okay? Most of in your data sets, you're going to have correlations of like 0.7, 0.8, very high correlations. Because like, for example, heart rate and blood pressure, they're like, you know, there's an equation, isn't there? Like, yeah, so it's perfect. But in most of the time, it's not like that. I have, like, if I got a 0.8 in my world, I would like, you know, the coolest thing in the whole world. 0.7, I think, is the highest correlation I've ever found. Doesn't happen very much. So, in your assignment, you need to look at a scatter plot. A scatter plot is also called, in Spanish, we had some Spanish exchange people one year. Anyway, and I learned, I forget where they were from right now. Maybe they weren't Spanish, maybe they were Portuguese. No. I don't know. Doesn't matter.
Camilla?
No,
Where is she from?
Brazil.
Okay.
Which this was a long time ago. It was like people Dave works with still. Mario and December or something. Anyway, they, in Spanish though, the scatter plot means cloud diagram. Kind of thing, like if they're putting cloud. Sounds nicer. Cloud diagram, sounds pretty. So we have to create a scatter plot of our independent and dependent variables and discuss something about that. So why do we do a scatter plot? It tells you whether there seems to be a relationship between the variables. It tells you what kind of relationship it is, and it also tells us if there's a bivariate correlation or outlier. So you're going to learn in here in this that looking at diagrams gives you often a lot more information than looking at stats. You'll also find, for example, sometimes if you notice like Dave or Kevin or Dwayne's presentations, sometimes they don't even, there's not even a number on their whole thing, okay? It's just diagrams. So that's because the audience can understand that. It's more relatable than to anyone, too, and they can see it. So to do a diagram, a cloud diagram, or scatter plot, we now just need to go to our data and go to graphs, and it's called legacy dialogues. I have no idea why they called this weird thing. Sounds like you're going, like buying a car in Las Vegas or something. Legacy. And we go scatter dot. Click on that. You say simple scatter plot. I define it. I'm now going to put my activity restriction. Whoops. And obviously, okay, I'm not thinking about the axes right now. So you might. And that's it. I can make a title and all that. I'm not going to bother. And where's my scatter plot? There. I get this diagram. So this isn't, I switched the axes. Oh well. This doesn't look anything like a cloud. It looks very cloudless, okay? The reason is because one of my variables is really an interval level variable with only 5 categories, okay? You might find that the other ones you like up for your assignment, but you would be able to tell roughly from a relationship. For example, if we had a diagram that looks like this, that tells me, I can circle this thing, I can put a line through it. It's almost a perfect positive linear relationship. I could also see if there's some outliers that are all over the place. Okay? The more you do in physiological variables are going to look more pretty on a diagram, whereas these are social science ones are not as much. So I'm going to say something about this. I'm going to say, Figure 1 illustrates a scatter plot. It shows that there does not generally appear to be a relationship. However, it does kind of show that individuals with greater activity restriction had more depression. It also shows me that there's several outliers. People who were low activity restriction but had high levels of depression. I'm not going to do this. I'm just showing you here. I could have made a scatter plot and I could have divided it by people. A grouping factor. So here's gender. It's blurry. But here now I've got 2 colors, green and blue. Okay. Now I would never show that, but this is a terrible diagram to ever present in a class actually. Do you guys know why? How would you make this better visually?
Colors are kind of similar.
Yeah, first of all, 3 out of 10 males are blue or red colorblind. 1 out of 10 females. I know this only from when I taught this class. One year I had 3 guys who couldn't see anything. I was talking about which red line, which blue line. And I thought, this is statistically improbable that there's 3 colorblind people in the class. Then I looked it up, it was a class of 10. Perfect, it was totally normal. So, I've learned now, you shouldn't assume people can read colors. So I would put it in colors, but ideally, I would change the color, but I would make maybe the males to be triangles. Different shapes is much better. You must think about visual stuff. A lot of people can't see things in presentations. 3 out of 10 people men cannot see blue versus green. This is why I thought my dad just was bad at colors, but he's actually just like kind of colorblind, right? You're fine. Okay, I'm just gonna do a little bit. And there's no way we can finish this, and you guys should be able to go to the bathroom before summer. Okay, I'll stop here. We'll finish this. If you've read through all of this, you're gonna be able to do it for your assignment if you want to get it done. Basically, if you go through it, you just have, for the assignment, there's a whole bunch of different correlations. And depending on the level of measurement and whether it's normally distributed, you pick a certain one. And that's really all it is. I think for your assignment, the only things you can do is Pearson or Spearman. The data won't be normally distributed, so you gotta use Spearman. Process elimination. Pretty much. That's how it works. But I'll go through this, and then, you know, if you, this assignment is technically due next Friday by midnight, because we're not quite finished this, like, you know, you can hand it in on Sunday or something. Won't make you rush, but you're welcome to hand it in early. Oh, and I'm looking at your first assignment this weekend, I just haven't had time. It was reference week, and, I don't know what else.
You want our page, your page on bullet thing next Friday too?
If I say that, in the assignment, in the, it's whatever particular. So you're gonna learn that I have no way, I only, you know, week by week kind of gal, okay? I have this all set, organized, but I don't think about it that way. So yes, I could. You have, no, it doesn't say that. What does it say? Do I say part 1? Okay, yeah, February 8th, yeah. Okay, so remember you've got to figure out what your topic is going to be for your methodology. Okay? If you're doing it, come and talk to me if you want to actually do a data set, okay? But you need to find it. If you're doing the critique, you need to pick a topic and at least locate some references. Okay? There's no marks for this. This will take you, like, should take you less than, I mean, some of you might already have all this done. Like, it might take you literally 5 minutes to hand that in. But if it's a new topic, you have to look. Okay? So speak to you know, most of you're just doing your topic as your thesis. Okay? So you're gonna, for example, you're just gonna do like obesity, metabolism. That's not what you do. You know, who's on the obesity? You don't know. Is anyone doing obesity? I'm working on that. Okay, that's different. Okay, well, then like you're just, okay, so MS, you'll just look at like all you already know what your topic is, so just find the article. I assume like most of you guys have articles already for your thesis? Yeah, gathered? Yeah, so you're just gonna use those, it's not a big thing. People who don't have any idea what they're doing yet will have a harder time. Okay, because you want to pick something like, for example, Audrey. You guys know Audrey? Yeah. She's been here for 100 years. Okay, when she took this class, she was originally with Jeanette and she was doing yoga, physiology, and anatomy. Okay. She did her whole thing on yoga for this whole assignment. At the end of this whole class, I felt really bad because at the end of this class, she realized that studying yoga was going to be really hard, and Jeanette agreed. And then she dropped it and switched supervisors. So, but that's how you might find it. Okay, so that's why she's taking so long too, is that she switched topics so many times. Okay.
Yeah, I was just on swing. I'm working out at the root now. That means that there's not many articles.
What do you do?
I'm doing weight shape. So we're looking at the squat with the barbell back squat, the overhead squat, and we're putting like the band weight for underneath and like looking at like the EMG all.